Alright, so for homework I asked you to do 6 2 evens, so let's go ahead and do that. Alright, so for the first two problems, first three, it asks you for the amplitude, period, and phase shift. So, let's see here, for number 2, it says y is equal to 10 times the secant of theta. Well, theta is by itself, so the amplitude is going to be none because it's not sine or cosine. The period of secant is 360 divided by 1, which is 360, and there's no phase shift. Number 4, y is equal to 1/2 sine theta minus pi over 3. Theta is by itself, nothing to factor out. The amplitude would be 1/2. Period is normal period of sine divided by the number in front. And the phase shift is pi over 3 to the right. And then number 6, it says y is equal to negative 1.5 sine of 4 theta minus pi over 4. So we have to factor out this 4 to figure out those components. And we're getting pi over 16. So the amplitude here would be 1.5, absolute value of negative 1.5. Normal period of sine is 360, divided by 4 is 90. And then we have pi over 16 to the right. For number 8, let's see what we have here. 8 and 10 are similar. I think 8, it's asking for sine. And 10, it's asking for cosine. Alright, so for number 8, it's saying amplitude's 4, period's 3 degrees, and phase shift is negative 30. So a negative 30 phase shift means we are actually going to the left. So it would be plus 30 degrees. On the test, I'll tell you left or right, so you don't have to remember. But if we're going to the left 30 degrees, which is what I'll tell you, you should put plus 30 degrees. The amplitude's 4. And then the way we get this k value is we do the normal period divided by k should equal 3. And in order to figure out what k is, you multiply both sides by k. And if you divide by 3, you get k is 120 degrees. Or k is just 120. For number 10, it's going to be similar except we're using cosine. Amplitude's 12, period's 45 degrees, and phase shift is 180 degrees. In the test, I would tell you it goes to the right. So we're going to put minus 180 degrees. The amplitude is 12. And in order to figure out the period, we take our normal period of cosine divided by k, and that's going to be 45. Well, 360 degrees would equal 45k. Multiply both sides by k. And if you divide 360 by 45, I believe it's going to be 8. I think, let me see here. 360 divided by 45 is 8. Yep. Alright, so that would be the answer. We have a couple of graphs to do. For number 12, it's asking you to graph y is equal to 2 times the cosine of 3x. I had told you in the notes that it's okay to use degrees for all of this. I have an amplitude, period, and phase shift. There's no plus or minus, so the phase shift is 0, the amplitude's 2, and the period would be the normal period divided by 3, or 120 degrees. Every 120, it's the same thing. So for a problem like this, it's a good idea to make a table. I always ask you to graph from negative 360 to positive 360. And let's see what happens here. I'm going to type it in like this. Alright, so start at negative 360. I'll plug in a few values until I start to get the idea. And then we'll connect the dots. Alright, so let's store negative 360, store it for A. I'm going to type in 2 times the cosine of 3A. And I get 2. Negative 270, store it. Calculator's telling me it's 0. Negative 180, store it. I'm getting negative 2. Let's do negative 90, store it. And I'm getting 0. Store 0. See how quick it is. I'm getting 2. And it looks like the graph, now it's a little confusing, right? Because it should have a period of 120. So you don't want to just do this, because that would have a period of 360. It's actually repeating every 120 degrees. So watch, ready? Negative 360, 120 degrees later, it's going to be the same thing. So negative 360 plus 120 is negative 240. Here, I'm going to label this. So you just have to be careful. It's not hard, but at negative 240, it's going to be the same thing. Negative 360 plus 120 is negative 240. Add 120 to that, a period later, it's negative 120. Add 120 to that, and you get 0. It's the same thing. So it's looking a little bit different. Add 120 to that, and you're going to get the same point. Add 120 to that at 240, and you'll get the same thing. Add 120 to that, and you'll get 360. You'll get the same thing. So you see what I did here? Every 120 degrees, I put the same thing. Let's see, at negative 270, the value is 0, right? So when's the next time it's going to be 0? Well, negative 270 plus 120 is at negative 150. Plus 120 would be negative 30. Plus 120 is 90. Plus 120 is 210. Plus 120 is 330. So let's go ahead and graph this then. Negative 150 would be maybe like over here. And it's going to be the same value as negative 270. 0. At negative 30 degrees, maybe like over here, it's going to also be 0. At 90 degrees, it's going to be 0. At 210, it's going to be 0. At 330, let me see here. It's going to be 0. So really, the graph's looking like this. Something like that. Oops. Now it's a little bit tricky to draw, but we get the idea. It looks like every 120 degrees, like from 0 to 120, you see how it looks like the same thing? every 120 degrees it's the same thing. So it starts up, and then it goes down, and then at 120 it's up again. So the graph would look something like this. It's a little tricky to draw, but hopefully that's a good explanation for you. All right, let's do the last graph here, number 14. It says y is equal to the tangent of x plus 60. Okay, so we'll do the same thing we always do. Amplitude is none. It's not sine or cosine. Period of tangent is 180. There's nothing in front of x. It looks like the phase shift is 60 degrees to the left. So just to kind of put this in perspective, we know tangent usually looks like this. Right? So what this graph's going to look like, if it's going to the left 60, this 0 is going to be to the left 60 at negative 60. Graph's going to look something like this. The asymptote that's usually at 90 is going to be 60 degrees to the left at 30. And then this is going to have an asymptote at negative 150. So the graph's going to look something like this. That's what phase shift does. It moves the graph. So let's see if we could find some points, and we'll try to graph this. And we're going to be practicing this some more for the rest of the week. Alright, let's see what we get here. So we'll use our usual points, go up by 90. Alright, let's see what happens here. So I'm going to type in the tangent and variable a plus 60 degrees, and I'll start at negative 360. And my calculator is telling me that that would be 1.7. It means 180 degrees, it's the same thing. 180 degrees, it's the same thing. 180 degrees, 180 degrees, using the period to draw the graph. At negative 270, we get negative 0.6. 180 degrees later, 180 degrees later, 180 degrees later. Alright, so still not 100% sure I know what this looks like. Let's try negative 180, store for A, and the answer is 1.7. Oh, well, we already knew that, right? Because that's 180 degrees later. So what does this graph actually look like? It's hard to tell from the points that we have. So I'm going to pick some smaller points. Why not use like negative 45 and positive 45? Let's just see what that does. Negative 45, we have 0.3. $180 degrees later. 180 degrees later. Let's see here. Negative 45 plus 180. That would be at 135. 180 degrees later. That's 315. All right. And looks like the graph's looking something like this. Negative 45, negative 225, it's the same thing. All right, so how do we connect these dots to make it look like it should? So I know tangent does look like that cubic function, right? So usually at 0, the graph would look like this. So if we're moving everything to the left 60, my guess would be the graph would look like this. Something like that. Right. So that's what I would accept for the graph. If we moved all of these points 60 degrees to the right, we would get the normal shape of tangent. All right, so we'll practice some more. Thanks for following along. Talk to you soon.